This presentation deals with two projects involving digital-human collaboration in evaluating university courses. Our research questions whether pedagogical tasks should be delegated to machines which can simulate human communication and empathy, but lack inborn sentient awareness based on human emotional empathy. While AI can amplify educational data processing exponentially, it possesses only cognitive empathy, not emotional understanding. The approach followed here is Roy Bhaskar's critical realism. Critical realism takes into account not only the laws of electronics or cybernetics when developing AI application, but also the causal laws which shape decision-making. Critical realism also accommodates system thinking and shows that social systems influence digital-human collaboration, and not just technosystems. There are three aspects in the theoretical framework informing our projects. Hanson's model, which gives insight into digital-human interaction. The difference between AI tools and agentic AI. And the systemic model of online course design. These are explained in this and the next few slides. Hanson's model shows how interactive processes can be enhanced with AI tools, including what AI tools are capable of in any process, including pedagogical ones. It suggests how artificial intelligence and humans can best collaborate in terms of which processes can be delegated to AI tools and which should be done by humans. Hanson's model is adapted very slightly from its initial source, which is given in slide 5. Hanson's model is adapted very slightly from its initial source, which is given in slide 5. Hanson's model does not show the difference between AI agents and agentic AI. AI agents are specific AI tools designed to perform simple tasks as specifically directed, while agentic AI shows many aspects of human thinking and is touted as replacing many functions which human educators now perform. Copilot is one of the better-known forms of agentic AI. However, it cannot perform tasks requiring judgment or experience, which require abductive or human-centric processing. How does one brief AI agents and agentic AI with human understanding and judgment? Our solution was to use a systemic model of online course design to input human experience and judgment into the digital applications developed. The systemic model identifies 5 essential functions which need to be performed in order for learning to take place effectively. By effectively, we mean to achieve the desired outcomes. The functions are considered to be a generalizable principle. This principle has relevance for course design as follows. The contextual function relates to the social context in which knowledge is constructed, requiring the course designer to decide how learning is to be contextualized. The ideational function relates to the source of knowledge to be constructed, or the process whereby knowledge actually comes into being. The interactive function requires that, as knowledge is constructed in learning interactions, the course designer needs to anticipate how participants will interact. The social function requires that the social parameters, conventions, or constraints operating in a given learning situation need to be identified and made explicit to learners. The reflexive function relates to how participants will reflect on and assess their performance in constructing knowledge. Two projects are mentioned in this presentation. Project 1, Course Design Evaluation. Using Agentic AI, Copilot, to create a course design evaluator agent that analyzes course design based on textual analysis. Project 2, Course Experience Evaluation. Using a simple AI agent, the Moodle survey tool, configured by humans to evaluate the actual course as experienced by participants. Both projects required human judgment, experience, and an ethic of care to be included in the briefing given to the AI tools. Until data is obtained from actual use by students, registered on official university courses, and from academic staff, a detailed analysis of results and substantive discussion is not possible. Both projects are work in progress, with only the course design evaluator sufficiently completed for its current purposes. When tested, the evaluator provided comprehensive course design evaluations, including recommendations for improvements, on 2 online courses within 30 to 45 seconds. This AI tool has the potential to relieve human educators of tedious course design evaluations. Our conclusions realized the value of human experience. The developmental approach to these projects, with publications at each stage, made the authors more aware of AI project work as an exploratory process, with peer and other feedback needed at various stages. This process is more intuitive creative than logical deductive, and thus gave AI tools the perspective they needed to carry out the work. Human judgment was also involved. Feeding experience into AI applications contributes to successful collaboration. Emotional empathy is an important part. Students need to feel that instructors are there for them. Finally, we realized the value of a collaborative approach combining human experience with AI efficiency. In conclusion, this exploratory work is informed by long-term practical pedagogical experience and research, something that AI cannot work out by itself. The problem of how to inform digital tools with human judgment was solved by using a course design rubric based on experience and research. In conclusion, we appreciate your engagement with our research on digital-human collaboration in higher degree course evaluation. We welcome your questions, insights, and potential collaboration opportunities. This presentation deals with 2 projects involving digital-human collaboration in evaluating university. This presentation deals with 2 projects